Let's talk about the code you import into your projects. Have you ever really truly stopped to think about what it can actually do? Well, today we're diving into Merg-E, a language that was built from the ground up to answer that exact question, and it does it with a pretty radical take on security. Let's break down how it all works.
First up, we're going to tackle a huge, often invisible security flaw that's present in most programming languages, something called the ambient authority problem. Then we'll see Merg-E's solution. Everything starts with zero power. From there, we'll find out where power actually comes from with something called the ambient tree, see how to safely bring in outside code using merge, and finally, get to the real secret sauce, how you grant permissions explicitly and only give what's absolutely necessary.
All right, so every time you add a dependency, you pull in a library to handle dates or make network requests, you're placing a massive amount of trust in code somebody else wrote. But what happens when that trust is broken? Merg-E is designed to confront this risk head-on.
This is the million-dollar question, right? When you import a library, what powers does it get? Can it read your files? Can it send data over the network? In most languages, the answer is pretty terrifying. It gets all the powers your main application has, simply because it's running. This is what we call ambient authority. It's the permissions and capabilities that code just soaks up from its environment.
Think of it like this. A standard import statement is basically like giving a stranger a signed blank check. You hope they'll only write in the $20 they said they needed, but there are zero technical controls stopping them from writing in 1,000,000 and cleaning you out. This is the root cause of so many of the software supply chain attacks we see in the news.
So how does Merg-E get around this? Well, it flips the entire model on its head. It operates on a simple but incredibly powerful idea, the principle of least authority, which basically means code should only have the absolute bare minimum power it needs to do its job, and nothing more.
And this quote just brilliantly captures the mindset shift. In most languages, the default is risky. Everything can be changed unless you go out of your way to mark it as const or unchangeable. Merg-E does the exact opposite. Safety is the default. Everything is constant unless you explicitly use the mutable keyword to introduce risk.
This whole philosophy extends to entire files. A Merg-E module, which is just a file that ends in .mrm, is born completely powerless. Imagine it exists in a sealed, soundproof room. It can't see the file system. It can't touch the network. It can't do a single thing outside of its own little box.
And hey, this isn't just a philosophy. It's baked right into the language spec itself. You can see it on this slide. Notice you've got your main app files, the MRGs, and your module files, the MRMs. Now track down to that last row, ambient. That's where all the system authority lives. And for a module, it's a big, fat no. It's cut off from power at the most fundamental level possible.
Okay, so if the modules start with zero power, where does any capability, like even just printing to the screen, come from? It all has to originate from one single, highly controlled source. And that source is called the ambient tree. The best analogy is to think of it as the main power grid for your entire building. It holds all the potential electricity, the ability to write files, make network requests, the whole shebang, but it's all locked away behind a master switch. And only one thing is allowed to flip that master switch, your main application file, the MRG. This line of code you see here is literally the application declaring, okay, I am now connecting to the power grid. Meanwhile, all those other modules, the MRM files, they all remain completely off the grid. Okay, so we've got our powered-up application and our completely powerless modules. How do we get them to work together safely? Well, we don't use import. We use a much smarter command. This is where merge comes into play. It performs what the spec calls a surgical localized import. I absolutely love that term. It's not about giving a library access, it's about carefully pulling just the piece of logic you need into your own secure environment. It's like hiring a specialist contractor to perform one and only one specific task.
Now, this is the crucial part. This merge statement doesn't grant any permissions at all. It literally just copies the code for the isPrime function from that powerless utils.mrm module into our application. So the specialist is now inside the building, but their hands are tied. They have no tools, no keys, and no access.
This brings us to the final and most powerful piece of this whole puzzle. How do we give that powerless merged code the exact tools it needs to do its job, and absolutely nothing more?
Let's be perfectly clear on this.
Even though the is prime code is now inside our application, it's still in a sandbox. It can't see our variables, it can't call our functions, it has zero authority.
This is the magic. Do you see that OK count block? That is called a capture block. It acts like an access badge. With that little piece of syntax, we are explicitly handing the isPrime function a key to exactly one thing, our mutable OCount variable. Now it can read and write to OCount, and that is the only piece of our application state it can touch.
And the control gets even more granular. This second block, the one with maxPrime, is for granting read-only access to constants. So this means the function can see the value of maxPrime, but the language guarantees it is physically incapable of ever changing it. That is surgical precision.
So let's just put it side by side. The old way is import. It's based on implicit trust, and it gives away broad, scary authority. The Merg-E way is merge plus a capture block. This is based on explicit auditable permission. You grant access to exactly what's needed, and you deny everything else by default. It's a complete game changer.
So why does all this matter? Well, it means your security model is actually auditable. You can look right at the code and see exactly what permissions are being granted. It dramatically shrinks your attack surface. Even if a dependency is malicious, the damage is completely contained to only what you explicitly handed it. It enforces that principle of least authority, which is a cornerstone of building robust software, especially for critical stuff like what's being built for Web 3.0.
And that just leaves us with this final thought. Merg-E's design challenges a really fundamental assumption we make in software. It makes you wonder, what would the digital world look like if all our software was built with this level of intentional safety, with security as the default foundation, not just some feature we try to tack on at the end?